Today in this lecture, we will be studying about the determination of chemical oxygen demand of water. The test method is Open Reflux Method, and the IS code used for this test is IS 3025 Part 58 2023. The COD determines the amount of oxygen required to oxidize organic matter chemically using strong oxidants K2Cr2O7 in acidic environment under reflex condition. By this test we determine how much the degree of pollutant present in the water. For this test we prepare two solutions, ferrous ammonium sulfate and potassium dichromate in the laboratory. For this we take 5 to 600 ml of the distilled water and then acidify with the H2SO4, 20 ml H2SO4. Then we weigh ferrous ammonium sulfate 39.20 grams, dissolve in this distilled water. In this distilled water we dissolve and then we transfer it into the volumetric flask. See that all the particles are transferred by rinsing in the volumetric flask. We make it 1000 ml. By adding more distilled water, our solution is ready for the test. We should store properly by leveling it. So that is how we prepare our ferrous ammonium sulfate for the titration. Then we prepare another important solution. This is potassium dichromate. In this we take potassium dichromate 12.259 gram, dissolve in 5 to 600 ml of the distilled water, then add 120 milligram of sulfamic acid, then stir it well so that all the particles are mixed together, and then we transfer again in the volumetric flask, make it 1000 ml by adding more distilled water. So our this solution will be ready for the test. The normality of this solution will be 0.25. Now we can calculate properly since we have taken 12.259 gram of this element potassium dichromate multiplied by 1000, and this is equivalent weight of A2Cr2O7 49.03 into 1000. We have taken volume of 1000 ml. So the normality of the solution will be 0.259. Such solution will have the normality of 0.259. Again, we take the, since it is the COD of medium range, so we take 25 ml of the solution in the with the help of pipette in the reflex flask. In the reflex flask, the special flask, there is tubes also and reflex flask so that it can be heated on the heating element. So we transfer into the, with the help of pipette, 25 ml in the reflex flask, 25 ml in the, ensuring that the flask was properly cleaned. Then we add mercuric sulfate 0.48 gram, mercuric sulfate exactly 0.48 gram, and mix it properly. Then 10 ml of the K2Cr2O7 potassium dichromate, 10 ml. What we have prepared, 10 ml of the potassium dichromate, we mix in the 25 ml solution, means to HgS4 0.48 gram and plus this potassium dichromate 10 ml. Then we add silver sulfate and sulfuric acid reagent 30 ml. It is already prepared. We keep in the laboratory and we add this 30 ml silver sulfate Ag2SO4 plus H2SO4 solution. So our sample is ready for the test. We added mercuric sulfate 0.48 gram, 10 ml of K2Cr2O7 and 30 ml of reagent silver sulfate and sulfuric acid reagent. Then we add the condenser to it and then we start heating for the 2 hours. Maintain reflex for 2 hours. The organic matter oxidized till the organic matter is oxidized, and consume potassium dichromate. Whatever potassium dichromate is required for the oxidation of organic matter is consumed. So we keep in the fresh condition in heating condition at 150 degrees centigrade plus minus 2 degrees centigrade for the 2 hours. Then we cool it down and take out all the solution in the conical flask for the further testing. For the further testing, we add 150 to 200 ml of distilled water, 150 to 250 ml of the distilled water, add 2 to 3 drop of Fryne indicator. Add 2 to 3 drop of Fryne indicator into it. It will turn blue green. It will turn blue green. Then we titrate with the ferrous ammonium sulfate. Ferrous ammonium sulfate. It will be reddish brown, then wine red. Then we record the amount of ferrous ammonium sulfate taken from blue green to become wine red, and that record is maintained as the ferrous ammonium sulfate as a tight amount of volume of the ferrous ammonium sulfate consumed in making it blue green to white wine red. Now we will make the calculation to determine the COD. For determining the chemical oxygen demand, we another parameter required to titrate the blank sample, means distilled water in blank which will not have any organic matter, with the similar procedure. Then we take the 25 ml of distilled water, add the mercuric sulfate 0.48 gram, then add 10 ml of Cr2O7, 10 ml of Cr2, 10 ml of the K2Cr2O7, potassium dichromate, 10 ml, and then we add 30 ml silver sulfate plus sulfuric acid 30 ml. Again, distilled water 25 ml, mercury sulfate 0.4 gram, potassium dichromate 10 ml, silver sulfate, sulfuric acid and 30 ml. Digestion time again we keep for the 2 hours. Then we titrate with the ferrous ammonium sulfate of the normality 0.1 and the indicator is fluorine. So we kept for the reflex by adding the condenser. Keep heating for the 2 hours so that all organic matter oxidized with the K2Cr2O7 potassium dichromate, cool down, and then we add to 150 ml to 200 ml of distilled water. It will and add the indicator fluorine 2 to 3 drop. It will turn blue. Again we titrate to make it red wine and record the ferrous ammonium sulfate consumed in the titration. Once we recorded, we can record the observation from the blank and as per for sample 1, 2, 3, whatever sample we have taken for the test. So in this, we have taken sample distilled water for blank. Sample volume was 25 ml. Mercuric sulfate was 0.4 gram or 0.48 gram. We can take depending upon the requirement. Then K2Cr2O7 potassium dichromate 10 ml. This sulfuric acid and silver sulfate solution reagent 30 ml. Digestion time we kept for the heating 2 hours. Then ferrous ammonium sulfate normality 0.10 normal solution we have taken. Initial Buret rating 0.0 and the final Buret rating we received for this 22.50. Likewise for sample 1 Ganga river water, that sample volume was 25 ml. We added HgSO 4.48 gram. We have taken potassium dichromate 10 ml. Then sulfuric acid and silver sulfate 30 ml. Refresh condition 2 hours. We kept heating for 2 hours, and the ferrous ammonium sulfate normality of 0.10 taken for the titration, and then initial reading was 00 and the final reading has come 20.80 in the burette. We record how much FAS has been consumed. It will be always less than the blank, because in the blank there will not be organic matter. So more potassium, this ferrous ammonium sulfate will be required for the titration. So it will be always, for the blank will be always more than the for the sample since it will have the organic matter into it. Then sample to 25 ml 0.48 grams, 10 ml K2Cr2O7, 30 ml sulfuric acid and silver sulfate. We kept in 2 hours for the in heating condition. FAS again normality of 0.10 normality has been used and the final reading has come 20.70. So for determination of COD, for the unit is milligram per liter of O2 oxygen. A minus B into N into 8,000 divided by volume. A is ferrous ammonium sulfate consumed for the blank sample in milliliter. B ferrous ammonium sulfate consumed for wastewater sample in milliliter. Normality of FAS 0.1 N. Then volume of sample in millimeter. Volume of sample in millimeter. So for the first sample, the blank sample consumed the ferrous ammonium sulfate 20.50 and the organic matter sample 1 consumed 20.80. A is 22.50 minus B is 20.80. B is 20.80. Then normality is 0.1 of the ferrous ammonium sulfate into 8,000 and the volume taken is 25. 4.4 milligram per liter for the sample number 2 22.50. The FS consumed is 20.70 into normality 0.1 into 8,000 divided by 25. It has come 57.60 milligram. So average COD milligram per liter 54.4 plus 57.6 divided by 2 56.0 milligram per liter of oxygen. So interpretation less than 20 very excellent. COD if it is in milligram per liter of O2. If it is less than 22 excellent. 20 to 50 good. COD in milligram per liter of O2 50 to 250 moderately polluted. If it is 250 to 500 polluted and greater than 500 highly polluted. So our average COD has come in milligram per liter of O2 56. Hence it is moderately polluted. It comes in the slightly moderately polluted condition. It can be used for the consumption. So with this we have completed how to determine chemical oxygen demand of water. Thank you.